Hello, in this video we're going to look at trigonometric functions. Trigonometric functions is actually going to be seen throughout the entire course and including when you get to Cal 1, Cal 2, Cal 3. So it's actually going to be pretty useful to kind of understand the definitions of all your trigonometric functions. So we start off kind of simple where we look at a right triangle. So we know that this is a right triangle, and one observation that we can make, for instance, is that if we know that this is angle measure A and this is angle measure B and this is angle measure C, we know that for sure that basically A plus B has to equal to 90 degrees, and that's because we know that C is equal to 90 degrees also. But the thing of which that we kind of make mention of is that if we go ahead and we use a squared plus b squared, this is actually going to give us c squared. So this is known as the Pythagorean theorem. So most students tend to memorize, the idea of, the Pythagorean theorem. So like for instance, if I know that a ladder is resting against a wall, and let's say that that ladder is 13 feet, and then we have that the base of the ladder is 12 feet, then in that case I can actually figure out what is the height of which the ladder is resting against the building, for instance. So we would say that if you have that this is a, then that means that a squared plus 12 squared equals to 13 squared. So that gives you a squared plus 144 equals to 169. Now, once you do that, that's going to give you that a squared equals to 25. Now, what that means is that a is equal to 5. Now, for those that are kind of like thinking, but I thought it's plus or minus. Well, a is actually a measure of distance, which in this case means that it can't be negative. So that means that it can only be 5 feet. Now, the other thing of which that we end up talking about is looking a little at the x and y plane and the distance formula. So we kind of start by looking at, say for example, that we have the x and y plane. Well, one thing of which that we do know is that if we had a set of points in the x and y plane, let's say that we had, let's do like this and like that. So suppose that we had a triangle in the x and y plane, and specifically we're going to say a right triangle. Okay, now let's say that this triangle had the coordinates x1, x1, y1, and this had the coordinates x2, y2. And we'll say that this is going to be the point P, and that's the point Q. Now, we'll say that R is the one of which that it has the coordinate is x2, y1, but we're not really interested in that. So we have that this is going to be x2, y1. Now, what you would use is basically kind of like the distance, or you would use, yes, the distance formula, because we know that we can find the distance of P and R, and then we can find the distance of Q and R, which means that because this is a right degree triangle, that would give you the distance formula. So again, like we would say that if we're going to find the distance of P and Q, you would simply just say that this is equal to the square root of the side squared, because we're using Pythagorean theorem. So that's going to give you x2 minus x1 squared plus y2 minus y1 squared. And then we'll just extend this out. So this is the distance formula in any case, and it can be generalized to any sets of 2 points in the x and y plane. So we'll just call this the distance formula. Okay, now if this is the case, and that's, kind of like how you would find a distance from any sets of 2 points, then in that case, that means that what if we were to apply the distance formula to our standard position? Okay, so that's kind of interesting. So let me just move this up a little. And you're more than welcome to pause anytime that, you feel that it's going a little too fast. And I'll try to slow down a little bit. So we have that if we were to apply the distance formula in some kind of way to when you're looking at standard position. So remember that standard position is basically just looking at a terminal side. So let's say that we have our initial, and then let's say that we just project a ray like this. And let's say that this is going to be, let's see, let's say that this is going to be x, and then we'll just say that this is going to be y. Okay, now again, remember that the vertex or the origin is usually like with an O. So what this means is that we can actually do some drawing. Now, this point has coordinates x comma y. Now, we'll go ahead and say that this angle measure right here that forms with the initial position and the terminal side, or the initial side and the terminal side, is just going to be theta. So that means that we can find the distance from xy, and you can call it something if you want, to the origin. But note that the origin is the ordered pair 0, 0. Now if that's the case and we use our distance formula, then that's going to give us a nice little result. So let's go ahead and write down a little something more. So let's say that we have, this is going to be r. So we're going to say that this distance from the origin to this point right here is going to be r. Okay, now this is a little overdoing it because I can see that basically that there's a right triangle that forms as I drop the altitude. If you can see that that's just going to be um, what I'm about to derive, then just skip over to the end result. So in finding the distance, we say that basically that you're going to have that r, it's going to be equal to the square root. So r is just the distance in this case. So r is equal to the square root of x minus 0 squared plus y minus 0 squared. But that's actually going to tell you that r is equal to x squared plus y squared. So we have that the distance is just the sum of the squares of the x component and the y component. So that's actually going to be pretty useful as it relates to what we call trigonometric functions. So here's where things get a little interesting. So the way of which that we start defining these trigonometric functions is with relation to the angle theta and also the x component and the y component. In the event that you've already taken, like, say for example, physics, then that means that this is just review. So we have 6 trigonometric functions, and the way of which that we define them is with regard in the following way. So this will be sine theta is equal to, well, the definition of sine theta is the y over the r. And then we also have cosine theta is x over r. Now, furthermore, we can define the function tangent theta as y over x, but there's a restriction. X cannot be equal to 0. Okay, well, the other functions that we do have are what we call the reciprocal functions. So we have cosecant theta equals to r over y, but that's going to be that y can't be 0. And then we have secant theta, and that's r over x, and that's going to be that x cannot be equal to 0. But you also have that cotangent of theta is equal to x over y, which means that x cannot be equal to, that should be y. Yeah, yeah, yeah. Let me just clean this up. So that's y. Actually, let me just do this. Okay, so that means that the y component can't be equal to 0. Otherwise, it's undefined. So these are the 6 trigonometric functions that you would be working with. Now, that means that any set of points in the x and y plane will always correspond to your 6 trigonometric functions. So, for instance, if we had that you had an ordered pair and let's say that it went like this, and that ordered pair let's say that that ordered pair was 1 comma 1. Well, in that case, that would mean that you would have to find the r, which the r would be equal to 1 squared plus 1 squared, which is equal to the square root of 2. So what that means is that you could find essentially the sign, because it's going to be y over r, which is 1 over root 2. But that's also equal to, if you rationalize it, square root of 2 over 2. You just multiply by the conjugate. Furthermore, you could also find the cosine of theta, which is x over r. But notice that it's the same coordinate, so it's root 1 over root 2, which is root 2 over 2. Furthermore, you can find tangent theta, which is, in this case, the easiest one. You have y over x, which is just 1 over 1, which is just 1. Now you can see that basically you can find the remaining 6 trigonometric functions based on the definition, because we found what r was essentially. So whenever you are given those two, then yeah, you can work this out. Now, in some cases, you might be given the r, but not one of the variables, which means that you just kind of work it out like an algebra problem. So let's do an example. Let's say that we have the following ordered pair, 12 comma 5. So we want to find sine theta, cosine theta, and tangent theta. So to do this, we can actually just go ahead and draw our x and y plane. And this is probably not going to be necessarily to scale, so we'll just put it like this. Okay, well, the ray will be something like that. And we'll just put 12 comma 5. Okay, well, we can drop the altitude, so that way we form a right triangle. We know that this angle measure right here is going to be theta. And then we know that this right here is going to be r. Okay, well, in this sense, that means that we kind of have everything that we need. We have 12, we have 5, and then, I think that should be it. So what that means is that we can go ahead and finish this by saying that r is equal to the square root of 12 squared plus 5 squared which, well, we kind of already did this problem actually. This is going to be the square root of 144 plus 25, which is equal to 169, which tells you that r is equal to 13. Now, okay, that's not actually the solution technically. It's actually going to be a little more to that, where you're going to find sine. So sine is equal to 12, or no, it's going to be 5 over 13, and then cosine is going to be 12 over 13. Now tangent, you're going to get that one for free because it's going to be just 5/12. And then that's it. Okay, now note that you could actually find cosecant because cosecant is just the reciprocal. So it'll be 13/5, 12/13, and then 12/5 uh, for the cosecant, secant, and cotangent. Now, I'll probably just go ahead and suggest that you try finding, let's say, like cosecant theta, secant theta, and we'll do cotangent. For the ordered pair, 3, 4. And you'll see that that one's not too bad in regard to, um, you'll see that this one's not too bad in regard to, like, the finding the R. Okay, let's try another example. Even though I gave you like one example right there to try on your own, let's go ahead and look at the following. So let's try to find um, sine theta, cosine theta, and tangent theta. Okay, so suppose that the ordered pair that corresponds to this example is 8, -6. Now, we can actually go ahead and, for instance, find what that looks like, for instance. So we know that you're looking at 8, -6. Well, interestingly enough, that's going to terminate in the quadrant 2. So we have that 8, and then we do something like this. And this is definitely not to scale. So we have 8, -6. Now the angle that's forming, we didn't really talk about that. The angle that's forming right here, it looks something like this. Okay, so, and then remember that basically you have that you can specify, like, for instance, like a coterminal angle, if you'd like. So this is still kind of the same thing, even though it's not in your standard position. It's still going to give you the same result. So you have that theta. Uh, theta, it's kind of like it's using a sort of like a reference angle, but we're not even there yet in terms of talking about like reference angles. But in any case, like if you're kind of wondering like why is the theta bigger, and then it's going in the wrong, you can kind of see it as maybe it's going in the wrong direction or something like that. But once you start looking at like reference angles, then you'll kind of see like, okay, yeah, it doesn't matter. It's kind of like the same thing. Because for instance, if this was 330, then that means that this angle is 30 degrees, which 30 degrees would give you the same exact thing, but just a different sign. Okay, so let's go ahead and find R. Okay, so r is going to be equal to the square root of 8 squared plus negative 6 squared. Okay, so this gives you the square root of 64 plus 36, and it looks like this is going to give me 100. So that means that the square root of that is 10. So that tells me that basically we can find that sine theta. It's going to be negative 6 divided by 10, but that's negative 3/5. Cosine of theta, that's going to be 8 over 10, which is 4/5. Now that means that tangent of theta is going to be negative 6 over 8, which is going to be negative 3/4. So we have that this gave us exactly what we needed. Now, interestingly enough, you can actually find the remaining, like cosecant is just negative 5/3, secant is 4/5 or 5/4, and then tangent theta is negative 3/4. Now, one thing that I kind of like about that ordered pair is that notice that, for instance, that if you were to kind of just look at something like this, where you have a right triangle, and then let's say that you have kind of like another right triangle, and you have that the angle measure is like both the same, and then let's say that this is going to be 6, and that's going to be 8, and that's 10. Well, in that case, like, this is 3, this is 4, and this is 5. My comments here are just to say that if you were to compare the two, you can say that, okay, yeah, these are basically similar triangles. So if you're kind of familiar with the 3, 4, 5 triangle, then that means that you could have easily probably just said, okay, well, then that means that the hypotenuse, or in this case, the distance of r, is going to be 10 units. So that automatically tells us that, yeah, we can find the rest of it from there. And that's just, a quick way that you can kind of think of it that way. And it goes the same thing, kind of like as you move along. Now, one of the next things of which that we can look at, for example, is how do you find the trigonometric functions when you're given a linear equation? Because, for instance, if we can kind of look at a equation in the form of ax plus by equals to 0, I know that in the x and y plane that it's basically just going to be either a positive line that looks something like that, or it's going to be a negative line which looks something like that. But it depends on, like, for instance, yeah, what restriction we might add on. Because, for instance, we're not really necessarily interested in the whole line itself. We're only interested in interested in a way that it resembles our rays. So, like, for example, let's say that we were to look at the following equation. What if we had 2x plus y is equal to 0? But then we'll add the restriction that x must be less than 0. If we graph that in the x and y plane, this is what it looks like. So in that case, we see that the angle measure is going to be like that, and it's going to tell us that we can find basically the 6 trigonometric functions. But the question is how, though? So the way of which that you would have to do that is you would have to pick an x value. So for instance, for simplicity, we can just choose x equals -1. Now keep in mind that you have to choose one that's less than 0. How do you find the y variable? Well, that's just algebra. So you have 2 times -1 plus y equals to 0, so y equals to 2. So that means that your ordered pair that we just chose is -1, comma, comma 2. So that tells you that we could have just chose any value for that matter, just as long as it wasn't 0, because then it wouldn't really give you anything. So, and remember that this angle measure right here is theta. And again, if you're kind of wondering, but I thought that, it had to be like where it's a right triangle. Not necessarily, because remember that if this is 150, that means that the reference angle is 30 degrees, which means that we can just project it into the first quadrant and then it's the same exact thing. So if I want to find the remaining, or if I want to find the trig functions, then I can. And how do I do that? I need to find r. Well, r is equal to x squared plus y squared, which will do -1 squared plus 2 squared, which is equal to the square root of 5. So what that means is that basically sine of theta um, is equal to 2 over root 5. And then we have that cosine of theta is equal to -1 over root 5. Now keep in mind that if you multiply by the conjugate, that gives you 2/5 root 5, and that gives you negative root 5 over 5. But I need to also find tangent, for instance. So tangent tangent of theta is just going to be, in this case, -2, because you have that's going to be 2 over -1, which is -2. Now for that matter, that tells you that the remaining functions, like cosecant of theta, well, that's just going to be root 5 over 2, and then secant of theta is going to be negative root 5, and then tangent, not cotangent of theta is going to be -1/2. Okay, so that means that we're able to find all 6, no matter if we have just in this case, a linear equation. Okay, so this is a linear equation in standard form, but the constant is 0, and that's because you want it to go through the origin. Okay, so in any case, like, it's almost like saying it doesn't really matter what point it is, just as long as it's corresponding to that equation. So we could have picked a closer one, or we could have picked a further one. Nothing's stopping me from choosing -10, but it still gives me the exact same thing. So one thing that we can do is say, for example, that we look at right, so let's say that, for example, that you look at 3x, and we'll do this as an example. Let's say that you have 3x minus 2y is equal to 0. But let's say that in this one you say that x is greater than or equal to 0. Okay, well, for instance, let's say that you want to find just like let's say cotangent. Let's say cotangent theta and cosecant theta. Okay. Well, in this case, like, what we would have to do is we would have to just say that we can just pick whatever x is, but let's do it like this. Let's go ahead and say that you have that 3x minus 2y is equal to 0, and you're going to rewrite that in the following manner. You're going to solve for y. So y equals to 3x, and we'll divide by 2. Okay, now all that I did was I just wrote it in a way that it's going to make it easier in terms of like finding ordered pairs. So when we graph this equation, and because x is positive, and because I wrote it in basically mx plus b form, you can kind of see that that's going to be a positive slope that terminates in the first quadrant. So that means that basically you have that the angle that forms with the initial side is like so. And here we just want to pick a point. Well, how about this? Why don't we just choose the ordered pair 2? So like for example, if we choose x to equal to 2, that means that the y variable is going to be equal to 3. So that means that this ordered pair that terminates right here that we can just choose is going to be 2 comma 3. Now keep in mind that that point, this line actually keeps going. So we're actually just being a little bit arbitrary and saying that, well, this is going to keep going really. So we'll just kind of do like something like that. Because yeah, I don't want you to get confused that, oh, but does that mean that it stops? No, actually it doesn't. It means that it keeps going. So I just chose 3, 2 as completely, not necessarily completely arbitrary, but just because, I don't know, it's a lot more convenient. So imagine if you have a line that just keeps going and then you kind of like drop like the altitude so that way you can see that a right triangle is then formed. So you have something like this. Okay, well that means that basically we can solve for the r. So the r is going to be given by plugging in the square root of 2 squared plus 3 squared, which is equal to 4 plus 9, which is equal to root 13. Now in this case, this is going to tell you that basically you have that, so cotangent theta is equal to x over y. So in that case, we sort of get this one for free. So it's going to be 2/3. So we have that cotangent is 2/3. But we can also find the cosecant. Is that the one that we want? Yeah, cosecant. So cosecant of theta is going to be r over y, which in this case means that it's just going to be the square root of 13 divided by 3, and that's it. So another thing of which that we can actually observe is that if you were to find tangent, so like we'll just put like a note, tangent of theta equals to 3/2. But notice something back over here. That's the slope. So in general, you have that whenever you have a equation like y equals mx plus b, you have that tangent of theta is always equal to the slope. And that's actually not really surprising because we know that the slope is defined by the rate of change, or the change in x, the change in y over the change in x, which is really just the slope. So we have that that's going to be just the tangent. Now, one of the other things of which that we'll kind of end with in this video is by looking at the quadrantal angles. So whenever we look at the quadrantal angles, we're talking about like if we were to divide the axes into quadrants 1, 2, 3, and 4. So remember that you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you want to use Roman numerals, you can. That way you're not like, oh, what is that, question 1? Okay, so this ordered pair is 0, comma 1. And we'll just put 1, comma 0 for this one. And then we'll put negative 1, comma 0. And then we'll put we'll put 0 comma negative 1. And just as a reference, we're saying that this is in regards to the quadrantal angles. Okay, so that means that we can basically kind of find the trigonometric function values. Now note that basically r has to be equal to 1 in every single quadrant, no matter what the point is, so we know that it's equal to 1. Because if you look at the distance from here on, you know that that's just going to be 1, 1, 1, and 1. I guess I should have just put it right here, right there, and right there. And then we wouldn't need to repeat that because it's coterminal. But it's okay. So let's say that we do an example of where we want to find, let's see. Okay, so let's say that we want to find the 6 trigonometric functions, and we're going to look at 270 degrees and also 4 comma 0. Okay, now in any case, like one thing that we know when it comes to 270 degrees is that it's an angle which terminates along the y-axis. So we can just put this here. So we know that this right here is going to be 270. So the ordered pair that we'll just choose for that one is 0 comma 0 comma negative 1. And we already know that r is equal to 1. So in this case, what we'll do is we'll just say that sine of theta is going to be negative 1 over 1, which is equal to negative 1. Cosine of theta is going to be 0 over 1, which is 0. And tangent of theta is going to be negative 1 over 0, which is actually undefined. Okay, well, we can actually find the remaining of those trigonometric functions. So cosecant of theta, well, it's still going to be negative 1 because you just take the reciprocal. And then for secant, it's going to be 1 over 0, which is actually undefined. Okay, but that means that we can also find cotangent of theta, which is 0 over negative 1, which is actually just 0. Okay, so it appears that the tangent and the secant were the only ones that we couldn't really find. Okay, so let's see what we have for part B. Well, part B is the one where you have ordered pair 4 comma 0. So let me just draw it like right here. Okay, so 4 comma 0 actually looks something like this, where you have 4 comma 0. And I mean, we know that the terminal side is coincidental with the initial side, but in either case, like if we were to find the r is going to be a bit different, okay? Because you have that, it's going to be that r is the square root of 4 squared plus 0, but that's just going to give you 4. So what that means is that we can actually find the sine, which is just going to be 0 over 4, which is 0. Cosine of theta is going to be 4 over 4, which is just 1. And then tangent of theta is going to be 0 over 4, which is 0. Cosecant of theta is 4 over 0, but that's undefined. And then secant of theta, it's actually going to be just the same, it's just 1. And then you have that cotangent of theta is going to be 4 over 0, which is also undefined because, yeah, we can't divide by 0. Okay, so let's see. Well, yeah, that's it, isn't it? So um, we know that we can try several examples like 180, negative 180, maybe 9 degrees, or even like negative 90, or negative 2, 0, and so on. But it's going to give us kind of like the same results. Now, one thing that I do notice is that we do have that along the y-axis, you have that both tangent of theta and secant of theta were undefined. And we have that along the x-axis, that similarly cotangent theta and cosecant theta is undefined. Okay, well that's actually kind of useful because then it can tell you that you can find the remaining 6. So let's say that we kind of close this section by looking at the 6 trigonometric functions of the important angles, such as like 0 degrees, 90 degrees. Well, these are the quadrantal angles. 180 and 270. Now, I can do 360, but to be honest, it's going to be the same as 0. But I mean, we can just go ahead and write it if you want. Now, we can actually go ahead and say, okay, so we're going to have sine, we're going to have cosine, we're going to have tangent theta, we're going to have, let's see, we can write it like this, like cotangent of theta, and then we'll have secant of theta, and then we have cosecant of theta. So, for instance, if we go ahead and we kind of refer to, and we can just draw it really small down over here. If we refer back to, like where we have the different quadrants or the quadrantals. So like if you have 0, 1, you have 1, 0, you have 0, negative 1, and then you have negative 1, 0. You can actually find these pretty easily. Okay, so I know that the r is always going to be just 1, so let's just put that right there. So r is just 1. So sine of 0 degrees, well, that means that it's y over r, but in that case, that's just going to be 0. Sine of 90 degrees is actually just going to be 1. But then sine of 180, that's also going to be 0 because it's the same direction. Well, it's the opposite direction, so that means that it would be the same though. So it would be 0. Now 270, that's just going to be negative 1 because you have negative 1 over 1 is negative 1. And then it repeats as 0. Furthermore, you have that cosine of theta is going to be 1. Why? Because it's 1 over 1. Now you can kind of see that the pattern is that sine of theta for quadrantal angles, it's going to be either 1 or negative 1, and then cosine is going to be 1 or negative 1, and so on. So they kind of switch. So cosine of 90 is 0, cosine of 180 is negative 1, cosine of 270 is 0, and then that's just going to be 1. Okay, now tangent, this is going to be a little bit tricky. So we have that tangent okay, so we have that tangent of 0 is just going to be 0. Tangent of 90 is going to be undefined, so we'll just put undefined. Tangent of 180, that's going to be also 0. Okay, now we have that, let's see, tangent of 270, that's also going to be undefined, so we have undefined. And then that's going to be also 0. Okay, so now we'll do cotangent of 0. Now, 0 is along the x-axis, so we know that basically that this is going to be undefined. And then, let's see, we also know that it's going to be undefined at 180. So the rest is going to probably just be zeros. So we have that that's going to be 0, that's going to be 0, and that's going to be undefined. So we have that. That's kind of like the pattern that we can come up with as it relates to cotangent. Okay, now with secant, basically you have that with secant, it's either going to be 1 or -1 or 0 or undefined. So secant is going to be 1. Let's see. Yeah, secant is going to be undefined at 90, and then it's going to be -1, and then it's going to be undefined again, and then at 360 it's going to be 1. I might have said that secant is going to be 0, but actually it's not going to be 0 at all. And then finally, we can actually fill in cosecant of this. So cosecant is going to be, yeah, it's going to be undefined, which means that at 180 it's also going to be undefined. And that means that basically cosecant is going to be 1 for here, so it's going to be just 1. And for 270 it's going to be -1. And then over here it's still undefined. So this kind of gives you an idea of what's going on as it relates to like finding the angles. Now I will say that you can actually use like for instance if you use the calculator, as long as it's in the proper degree mode, then in that case like you can always type in those angle measures and then it'll give you kind of like the same thing. So like for example, if you do cosine of 270 and you click enter, it's going to give you 0. But if you do like for example like sine of let's see, not sine but yeah, yeah, like let's say like for example like you have tangent of 270 and then you hit enter, it gives you like an error message. So that means that it was undefined, right? Um, let's see. Now if you want to do like for example like the other functions like cosecant, uh, cotangent, and secant, well in the next section I'm actually going to show that to find like cosecant and secant and cotangent, you're just going to have to use 1 divided by each of these. So like 1 over sine, 1 over cosine, 1 over tangent. But I won't do that right now because that's not until the next section. And then last but not least, if you ever want to try to determine if your degree mode is in the proper, proper like it's in degrees, not radians, then you can always just go to mode and then just change it and then make sure that it's in degrees. But in any case, like you can test it by just saying, oh, okay, well, if I type in sine of 90 and it gives me 1, I know it's in degrees. Versus, like, if I had that it was in radians and you didn't check it, because, like, this kind of happens, because you borrow someone's calculator. So, like, if you typed in sine of 90, this automatically lets me know that it's in the wrong mode, that it's not in degree mode. Okay, so as we kind of like go into the next section, basically what you'll want to do is go ahead and just kind of practice finding those trigonometric functions, especially the ones for linear equations, because those are probably like the most challenging ones. But in the next section, we're kind of going to be doing some identities and things like that, but very, very minor because there's like another section later on about identities and proving them. But for the most part, really all that you need to do for now is just look at how do you take an ordered pair and then correspond it to the six trigonometric functions.